Hi guys, welcome to my YouTube channel, and this is Ramsha Mushtaq, and today I will teach you that how to make Tower of Hanoi game in Java. So starting this, first I will play this game so that you build the idea that what is this game and what are the rules to play. So if you know about that, what are the rules and what are the things that you should keep in mind when playing this game, you would be able to create your own logic, and I will tell you about my logic, and then it would be very easy for you to create this game in Java using some simple methods and creating your own method as well. So let's start it. So first I'm just running the program. So you can see that this program is displaying welcome to Tower of Hanoi game, and the rules are: the objective of the puzzle is to move the entire stack to another rod, obeying the following simple rules. Rule number one: only one disk can be moved at a time. Rule number two: each move consists of taking the upper disk from one of the stacks and placing it on top of another stack or an empty rod. No longer disks may be placed on the top of the smaller disk, and there would be three poles named as A, B, and C. Two options would be displayed on the screen: enter source pole name and enter destination pole name A, B, or C. Source pole is the pole from which you want to move the disk, and destination pole is the pole to which you want to place it. So, in simple words, there are just three poles in front of you: A, B, and C. A is fully filled. It has three disks. You can see that the disks are placed in such a way that the largest disk is at the end and the smaller disk is at the top. So you have to place all these disks from here, pole number A to pole number C, and there is an auxiliary pole number B, so you can take the help of this pole. So you can place these discs here, but the problem is that if I place this first disc to the C and then I try to place the next disc at this position, sorry, at this pole number C, so the smallest disc would be at the bottom, and the largest and the larger disc as compared to the previous disc would be at the top. So this would be wrong. You can't do this. You have to move all these disks to the pole C in such a way that the largest disk would be at the bottom and the smallest disk would be at the top. So I have explained the rules of the games, and now there is another note for us. So this program is telling me about that there are four categories of result. Like if I have four disks, like in the present case, yeah, I have four disks. So this puzzle can be solved in 15 moves. So if your total number of moves would be 15, you would be ranked as outstanding. Oh, that's cool. And if I solve this puzzle in the range of the moves of 16 to 20, my performance would be ranked as good. While if I make 21 to 30 moves, then my performance would be ranked as average. And if my total moves would be more than 30, then I would be ranked, my performance would be ranked as poor, and I will lose the game. Okay, so I've read each and everything. So let's play this game. At first, it's asking me about enter the source pole. A, B, and C. I have three options, so I choose A. A is my source pole, and now enter the destination pole. So now it is asking me that from where I can from where to where I want to move the disk. Like I've choose A as the source pole, so I want to move it to B pole or C pole. So my destination pole would be B. Okay, so you can see that now A has three discs instead of four, and B has one disc because I have moved it, and I can move this in such a way that from the top I can only take the disc. I cannot take it from the bottom. Okay, so now again it's asking me about source poll now, which poll I want to choose as a source poll. So I'm again choosing A, and I want to take my disk from A to C. So you can see that the second disk is also removed from A. Now I want to move my disk from B and take it to C. You can see that the disk is removed from B. Now I want to move from A and take it to B. Okay, now I will do some other moves speedily. So C to A, then C to B, A to B, A to C, B to C, B to A, C to A, now B to C, now A to B, and now A to C, and at the end B to C. So finally I have placed all the disks from pole A to pole C, and as my total number of moves are 15, and 15 were the minimum number of moves that were required to solve this puzzle, so I was ranked as an outstanding performance with minimum number of moves, and it is saying me congratulations, you won the game, yippee. So you can see that this is the game, and now you know that what are the basic rules behind this game and how to play this game. Now the most important part has been started. Now I will teach you that how to create this amazing game. So when I was trying to create this game, I just go to Google and just play this game and just study its rules. Then I started thinking about it and making my own logics, and then this program is the result of all the things. So it's very easy. This is my main class, and this is another class that I have created. So first I will teach you about this class. Public class Tower of Hanoi. This is my class name. So I have used some variables like move. Move is initialized as 0. It's of integer type, and as I move the disk from one position to another position, or you may say that from one pole to another pole, there would be an increment in it. The second variable is winner. Winner is initially false, but when it becomes true, it means that I have placed all the disks from pole A to pole C. Now, the winner is of Boolean type, and there is another variable which is of Boolean type. It is condition, and this condition variable basically, I have used this variable in different methods in such a way that if its value is true, it will indicate that yeah, the disk which is already present at the pole is larger as compared to the disk that I am going to place it. But vice versa, if the condition is opposite, like the disk which is present at the pole initially is smaller than the disk that I'm going to place, this condition become false, and it will tell the user that the user had made a wrong move, and please try again and make a right move. Okay, so and there are some other as well, like raw origin, raw destination. I will explain these variables later. So first you can see that this is my class, and this is the constructor that I have wrote. So in this constructor you can see that one thing more, yeah, most important, this is the two-dimensional array that I have created. I want to tell you guys that I have made this game by using two-dimensional array. So you can see that I have four disks and three poles. That is why I have created this four-dimensional array for four rows and three columns. So this is my array, and I am initializing this array in the constructor in such a way that the middle column and the last column or the ending column would be empty, and the first column, which represent the pole A, contain all the disk. So I have make this pattern for that. You can make any other pattern whatever you want, so you can do that. So this is the constructor, and this constructor will initialize this two-dimensional array in this manner. So let's move forward. This is my display method. The display method basically display the current status of the game, that you can see that whenever you place the disk from one pole to another pole, the current status of the disk is displayed in front of you on the console in the form of a pattern. So basically this do that, and that's why I've used print statement for that. So in order to understand it more accurately, I will show you a pattern on the paint. I've drawn this in order to make you understand that how the two-dimensional array is working correctly, and different patterns. Like this is the pole A, this is the pole B, and this is the pole C. You can see that I have made these boxes. This table, you might call it a table, like so you can see that there are four rows and three columns. These red lines show you four rows and three columns. This is column number one, this is column number two, and this is column number three. While this is, and in when we talk in arrays, so you know that where we started from zero, so we will say this is zero column, this is one column, and this is column number two. So there would be, this would be zero row, this would be one, this would be two, and this would be three. But actually there are four columns, sorry, four rows and three columns. So now I will tell you that how two-dimensional array work. So first, just forgot about pole B and pole C. Just focus on pole A. You can see that pole A is showing an array 0, 1, 2, 3. Okay, this is your array position at 0, at index 0. This is your array at 0. This is our array at 1, at 2, and then at 3. So 0, 1, 2, 3. And these black lines represent this vertical black line represent pole, and this horizontal black line represent disk. So you can see that this is disk 1, disk 2, disk 3, disk 4, and all these disks are placed at pole A. So if I want to make two-dimensional array, then two-dimensional array is basically any array inside an array. like you know that this is the pole A and 0 1 2 3 is basically your single array. But if I want to create a two-dimensional array, so each element at the index was basically would be an array. So that's why this array would start uh, horizontally. So this would be 0 0 position, this would be 0 1 position, and this would be 0 2 position. The next would be 1 0 1 1 1 2 2 0 2 1 2 2 3 0 3 1 3 2. So these are all the positions of the array. And you if I open the program, you notice that 0 0 1 0 2 0 3 0 contain the disk pattern. So if I open the paint again, you can see that 0 0 1 0 2 0 3 0 contain the disk, while 0 1 1 1 2 1 3 1 0 2 1 2 2 2 3 2 are empty. They don't contain any disk pattern. So if you see here, all of these are empty. So I think after looking the paint example, you can understand this constructor very well. Now let's move forward. This is the display, and this display, if you focus, this display is similar, um, like the fashion that I drew at paint. So you can understand this well. And after each move, I will call this display function so that I would know that what is the status of my game, and this pattern would make me understand that. Now let's move forward, and this is the solve method, and this is the main method and very important method, which basically decide to move disk from which pole to which hole. And it also use a function name as check, and that function basically check whether the last disk that is already present at the pole is larger than the disk that I'm going to place it or not. And like the story that I have already told you earlier, so before understanding solve method, we should build an understanding for check method. So I will first move towards check method. So you can see that this is the check method, and it is of the type boolean. Why I use the type boolean? Because I wanted to know whether this that the move that I am going to make is true or false. So if the move that I'm going to place is true, this check method will return true. And if the move that I'm going to make is wrong according to the game's rules, then this check method would return a false condition. And so I will inform the user that this move is basically wrong, and make another move. So as I have three poles, so I can use any pole for the destination. The pole that is this is the parameter pole that this function or method is using is basically the destination pole, the pole to which we want to move our disk. So this is the destination pole. And so you know that as we have three poles, so B can be the destination pole, C can also be the destination pole, and A can also be the destination pole. So that's why we have wrote this conditional statement for three poles. First, we will understand it for B, and if we build the understanding, then we able to easily understand it for A and C as well. First, you should draw the all the blocks and the poles at the paper. And you can just fix one pole and try to build all the possible conditions that that move can be made. So like that, I just first fix the disk 4. So if the disk 4 is the pole B has the disk number 4 already, then the first condition is that yeah, all the three other disks would be empty. It means that this is at 3 1. We should look this position. So I'm trying to say that, like, if the pole B has this number 4, then all of its three position would be empty. This is the case. Yeah, this case is possible. So this is a possible case, and I'm just fixing the disk number 4. Then the other case is that if the disk is at this position, the next condition may be possible, like the disk number 3 would be here and the two other would be empty. The next case, you can see the other case is that this the disk number 4 would be at the same position, but the 2 1 position contain the disk number 2 in spite of disk number 3. The next possible case is that, like this one, the next possible case is that the disk number 1 would be at 2 1 position. These are the four possible cases that can be made by fixing disk number 4 at the position 3 1. So yeah, I made these I just wrote this conditions and all would this would be true. Now I just wrote some possible condition, like uh, instead of fixing one disk and placing any other disk on the 2 1, I just start to make only one position empty and filling all other three position. So the next possible is case is that, like if the disk number 4 is fixed here and the at position 2 1 I have this disk, and at position 1 1 I have this, while the first is empty. So yeah, this is another case, and there are many other cases. So you have to just write all these four blocks, four, you might say, as four disks on the paper, and just fix one disk and just write all the possible conditions. So I just wrote all the possible conditions that can be made, that would be correct while placing the disk at the pole number 2. So now let's see, the again pattern is repeated for pole C and then for pole A. So this was our check function, and if this give a false indication, it means that we are going to wrongly place the disk. Now let's move towards solve method so we can build our understanding. Yeah, so this is our solve method. It uses two variable, rod origin and rod destination. Basically, rod origin and rod destination are the pole origin and pole destination. So rod origin is basically your source pole, and rod destination is basically your pole destination. So the you know that the game will ask you about that, from which pole to which pole you want to move. So these two variables will contain that. So from the main function, you will meet the input and enter here. like the let's suppose that the pole origin is pole number A, pole name A, and the destination is B. So this the first condition would be true. So you can see that if this condition become true, we have used a variable I, and it is initially 0. What this variable do? This variable basically check that which disk should be removed from your source pole. So you can see that I will explain it to you by using paint. So let's suppose that we should remove these disk. Okay, if you want to place this number 1 to pole B, your source pole is A and your destination pole is B, or your rod pole is A, or your rod origin is A and rod destination is B. So what you will do is that first you should check that is there is a disk at the top or not. Like if this disk is already moved to some other pole, the first position would be empty. So basically I will do that. I is initially 0. So rod 0 0. Rod 0 0 is basically position. So the program will ask that whether there is a disk or not. It will check that. So if it is equal to empty, it means that there is no disk. Like and if it's equal to the some pattern that I have entered, it will tell us yeah there is a disk, and if there is a disk, this will move forward, and this condition would become false. It would be out of the while loop, and then it will check. This is the 3 1 position, is basically this position. So the program will check is there any disk already present at this position or not. If it would be empty, it will place this disk from here to here. But if there is an already and disk, so it will move forward and move towards 2 1 position. So you can see that so it's checking that whether it's empty or not. So in our present case it's empty, so the condition become true, and it will just place that rod 0 0. I is basically 0 in our case at this time, like the condition that we are supposing. So it will move this disk to 3 1 position, and then it will just become empty. And after all this process, there would be an increment in move that I have just correctly placed the disk, so there would be an increment in move. Otherwise, if we suppose that this is already present, in the case this condition, all this if condition would become false, and it will enter in the else block, and now it will again check that whether the next position to 1 is empty or not. If it is empty, then it will just move the disk from A to B at to 1 position and check the condition check where if the condition check value is true, that the disk already present at the position, like this is the disk already present and we want to place this disk number 1 here, then the condition would be true and the condition statement become true. And if condition become true, then this if loop become true, and then the from the pole we want to place the item, like in the case it become 0 0, or that would become empty and there would be an increment in the move. Otherwise, if this condition statement become false, we will enter into the else block, and it will again just make the position empty and give an alert message that you have made a wrong move. And same is the case we have tried for all other positions. So you can see that the same is the process, and we have tried for all, like we want to move from A to C, or B to C, and same is the case. Okay, so this was our solve log, which basically make moves, and now I have wrote a function or method you can save to know about the total moves. So this function basically return me the total move, that how many moves I have made, and in order to check the status of move at any time, I have made this method move status, which basically return me the status of the move at any time. So these were the method, and we have left with uh, two methods: game status and get winner. Game status method will tell me about the status of the game, that whether I won this game or not, and get winner will tell me about that whether I have placed all the disks from pole A to C or not. So initially the winner variable is false, but if this method would be called, it would become true and it will return that. And in the check method, like you can see that if all the disks were moved from A to C of moves, then we will win this game. So we have to tell the program that yeah, now the discs are moved correctly from A to C. So just stop the game and tell us about the results. In the check method, this if condition, when the pole destination pole is C, when I just enter the condition and will the largest disk is at 3 2, smaller than that is at 2 2, and then other smaller is at 1 2, and the most smallest is at 0 2, like the one I show here. So when this condition comes in the game, it will call the get winner method, and get winner method will basically make the winner variable true. And when winner variable would become true, then from the main function we will stop taking the input from the user, and we will tell the user that these are the results and the status regarding the performance, that whether the user win or not. So now let's move towards main function. So this is my main function. I have import the scanner library from Java, so that I can use user input. And now you can see that here I have just uh, created an object of the class Tower of Hanoi, and I have two string variables, origin and destination, which will tell give input from here to the methods, and give which basically take input from the main function and will pass it to the class. So you can see that there are some rules that I have printed, that game rules and some notes that so that it would be easy for the user who is going to use this program, that what it's about and how it work. And then I have just called t.display. T.displays will display the pattern on the screen and tell us about the status visually. And then I have used this while condition in which I'm calling game status. You know that game status at this time would be false until you didn't place all the disks to the pole C. So if it is false, then it's not become true. It means that this while loop will continue to take the input from the user until um, the user didn't win the game. So here you can see that this message would be displayed on screen, that enter source poll name, and then this origin will get that input. And I used dot to uppercase as well, so that if the user types small a in spite of capital A, then still the program will understand that yeah, it's poll name A and this is our source poll. So you can see that this message would be displayed on the screen, enter destination poll, and it will get to know about the what is the destination poll, and replace the display. So this if condition basically check that whether the poll is A, B, or C. If like if the user um, uh, give input of any wrong poll, like it the user type D and there is no D poll in our program, so an error message would be displayed on screen, and it will tell the user that you have entered a wrong poll name, please try again. And again the user has the ability to enter another poll name. So you can see that after this I have called tmove status um, method. And if the move status are lesser, if when the game just all you have made all the moves and you are done and you have placed all the disks to the C, then this method will run and check how many moves you have made. If your moves are from 0 to 15, then the it will display that yeah, you have played awesome and outstanding performance with minimum number of move, congratulations, you won the game. But if your moves are between 16 to 20, it will display the message good performance, congratulations, you won the game. But if your moves are 20 to 30, it will display the message that average performance, but congratulations, you still won the game. But if you have used so much moves, like your moves would be greater than 31 to any other value, so it will display the message that poor performance and you will lose the game, because you have just used so many moves while displacing the disk from A to C. And at the end it will display your total moves that you have made, and this would end. So this was our game, Tower of Hanoi, which I created my own by just understanding that how this game works and creating my own logics. So hope so you will enjoy this video, and you will create your own games. You can create this game as well while thinking about this and creating your own logics. So because you now get the basic idea that how this game work and what are the methods that we should build while creating this game. And please subscribe my video and press the bell icon, so that if I upload some more videos you get the notification. And if you like my video, then please comment below. And please tell me about that if you wanted to learn how to create this game from scratch, then I can make one more video, and in that video I will just write the whole code and teach you from zero level. Thank you so much. Have a nice day.